Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
Hey, my friends. My name is Seth. I'm here to do an agentic voice mode unplugged. I'm excited to be here. I just found out that they changed the model on me. And so it doesn't seem to be working, but maybe we'll debug it and figure out what's going on. I thought I would start with, let me use the hand here. I thought I would start with sort of like what we're building. There we go. What are we building? And then number 2, we'll go into the back end for this. How does this actually work? And then number 3, we're going to do, we're going to show you some front end stuff. I showed this demo literally yesterday in San Francisco, and it seems to be kind of borked. So apologies for that. Let me show you a video of me running this thing, and hopefully you can hear it. And then I'll show you how it's actually built behind the scenes, and then maybe we can debug and figure out why it's not responding correctly. So this is a Contoso Outdoors thing, and I'm just going to hit play so you can hear like this particular interaction. What I'm going to do is I'm going to go ahead and start a chat to ask it about an upcoming winter adventure I am a little nervous about. Notice this is running directly in the browser, and it's responding the way you would think. Notice it knows about the picture as well as my actual question. But let's see if we can't up the ante a little bit and make the experience a little bit more personable.
Hi, Seth. It's great to connect with you. I understand you're gearing up for camping in snowy conditions. You've already got the Skyview 2-person tent, which is an excellent start. For a cozy and warm experience, I'd recommend a few more essentials.
This is amazing. I'm so sorry to interrupt you, but is there any way to show this to me visually?
Of course, Seth. I'll prepare a visual overview of these products for you. Please give me a moment, and I'll let you know when it's ready. Great! I'm sending the visual suggestions of the Mountain Dream sleeping bag, Rain Guard hiking jacket, and Power Burner camping stove to your screen right now. You should see details and images of each product, which will help you get a better idea of what they offer. Let me know if there's anything else you need.
どうもありがとうございます。
どういたしまして、Sethさん。こちらこそお手伝いできて嬉しいです。他に何かご質問やご要望があれば、お気軽にお知らせください。
Let me show you 4 ways that. All right, so that was the demo when it was working, right? But I'm going to show you how to build it. My sense is that something changed in the model, the way that the model works, and so we'll figure that out. But that's the experience I want to show you how to build. And we're going to spend the next hour going through this, and it's fairly low level. But I wanted to understand this thing and how it worked at the lowest of levels. And so let's start first with the actual model itself. So here you can see this is the actual thing. It doesn't seem to be working right now. Maybe we'll try it. Here, let's try it. So this is the same thing. How do I prepare for this? Do I prepare for this? And this thing is running localhost. So you can see the code running here. Well, it's the backend's not running, so it's gonna get mad at me. So I'll start that again. So notice it's disconnected. And so the idea is that there is a front end to this experience, which is this thing right here. And then there's a back end experience that handles all of this stuff. And it literally sends audio back and forth. And so let's see if the server started here. So we'll refresh that and see if it can connect. Yeah, so there it's connecting. How can I prepare for this? I prepare for this. And notice that it hits this backend, right? And this backend is a Python backend using FastAPI, and then the front end is using Next.js, the latest version-ish, right? And the answer, you can see that it comes back with the right answer. Can you call me? And this is the part that's not working all the way, but you're going to see things happening. So I'm going to respond. And you can see that it hears me, but it's just not responding. Right? Do you see that? So it's hearing me, but it's just not responding. I don't know what the deal is. Maybe I made a mistake on something, or maybe that the model changed the way it responds. So that's what this experience is. But right now you can see it's kind of not excited about life. So let me stop the call here and let's get into the backend. So part one, the backend. I wish I had like some music or something, you know, or those are not the right ones. Okay, so let's start with the backend. I'm using the real-time API from OpenAI. And with the real-time API, you have a couple of options that you can actually use to get audio into the model and get audio back from the model. And feel free to ask questions or get some comments. I'll be monitoring the comments because I'm more interested in responding to what you've got to say. So there's two ways of doing this, right? If you're trying to get stuff to work through the browser or with the real-time API, one is with WebRTC, and then the other is with WebSockets. When I started building this thing, this was the only thing available to me at the time. So WebSockets is what we use, but you can use the WebRTC version for getting audio back and forth. And so we'll set some debug points on the back end. So maybe we'll figure out like, hey, what the heck's going on? Did they change the model? Is the event different, for example? So that's the two ways. In the back end, if you want to communicate with the model, you have to use either WebSockets or WebRTC. So let me draw this here so we can get a little more clarity on what this means. So when you're actually working with this here, I don't need you. When you're actually working with models, right? You have your code that has to send audio to the OpenAI. We'll say OpenAI real-time API, and this is like literally audio waves. So like voice, you send those packets over to this thing, then it like gets a buffer full of those things, and then it's able to send audio packets back. Right? So we're doing it at the lowest levels. So these are just socket connections. And so we've got to find a way to get audio from our server directly to our from our server directly to the OpenAI thing. So that's the backend stuff. And so the best way that I thought that I could do this is if I look at the WebSockets implementation, you can see that like there's a server that uses a WebSocket, it connects through an API token, and it's sending audio back and forth to itself. And with Python, the cool thing about this is that you can fetch things from a socket and send things to a socket, and you can await and async await these two things, and it will just like send when it has enough, get when it has enough, and just create this loop. So let me show you how that is set up. Sorry, my mouse was in the wrong spot. Let me show you how this is set up. So it looks like I closed it. That's why it broke. So if we go to the main, in the back end. So let me delete this so it's not so scary. When I create a new connection to Azure OpenAI, in this case, I'm using Azure OpenAI and the GPT-4o real-time preview. Maybe the model name has changed or something, and I need to fix it, right? The idea is that from the client side, I create a WebSocket connection to my backend, and my backend then is going to take audio from the client and then push it back and forth from the OpenAI backend API. So in this case, this is the new system message I'm giving the OpenAI backend. I set up a real-time client. I update the session, and then this is that loop I'm telling you about. Like it's really cool because like each of the receive real-time and the receive client are like wild true loops that just are async awaiting each other. So it creates this like state machine. And this is the part that was hard to grasp initially, but you'll get it faster than me, is when I do a receive real time, I'm getting bits. I'm getting bits from OpenAI, which are audio bits. And I'm doing it like while the real-time API is open. The second bit is that I'm on the client side, I'm getting audio from the client or other messages in the socket. And so what's happening is when I do this, and notice that this is basically while true, or while the sockets are open, you will basically have, let me open this one too. Go to definition. Oh, it's the same thing, but in two places. So let me split right here. So it's open twice. So there's the receive real time, and then go to definition. Here's the receive client. Notice that these two things are like while true, but they're async and awaiting. And so this one gets its buffer failed. It's ready to do something. This one, and they're kind of like, they're not punching each other because that's not the right way to do it, or not to think about it, but they're kind of in an async await loop while true. And then this one, and then this one, and that's how the communication actually happens. And then I put that into an async IO gather loop. Okay, so hopefully if this doesn't make sense, that's okay. You can rewatch this or look at async IO stuff. But effectively, what's happening is this service gets audio, sends it to Azure OpenAI real-time, while at the same time it's receiving audio from Azure OpenAI. So this becomes basically a middle person between my UI and the model. Now we could connect directly, but because I'm actually doing the person in the middle thing, I'm able to do extra work on the side or send extra messages. Like, for example, hey, update your system message, or add a tool to your collection of tools voice API. Or so as the conversation's going, you can actually change how and why it's behaving the way it's behaving. And so that's why it's kind of nice, right? Because now I've created this API in the middle that can respond to what I want the voice API to do. And this is where this is the actual magic sauce that does it. This is while there's a real-time thing sending bits, and while there's a client sending audio, do it. And this was the part that, again, was hard for me to grok. But once I understood it, I was like, oh, so anytime I async await, and what happened is I did this demo in a keynote with like the boss. Early versions of this thing, because I was doing too much in the person in the middle situation, it caused the audio sometimes to stutter because there was too many awaits and async calls. And so you have to be pretty nimble with this thing in the middle. If you do too much, it might inadvertently await some long-running process in the wrong order, which caused the audio to stutter, which was tricky. Okay. So that's the first thing, number one. Number two, let's talk about the actual real-time API. So when you saw, I think I think you saw the Pamela put the OpenAI API. That's a lot. There you go. So this is a real-time guide. You can actually look at like how they set this up. But notice that this thing talks directly to real-time API. But I needed a person in the middle situation so I could run LLMs to do other things for other reasons. And so this made it so that there was like a command center of like the voice API thing. So this is where we get into the low-level stuff. And then I want to make sure to talk about how to handle this on the client side in an async way as well, because you don't want your audio coming in and out of your backend API, which is the one we're writing, to tie up your UI thread in the web browser. So you have to be tricky. All right, so this is the real-time API itself. And notice that in the real-time API, oh, they did change it. That's why it's now screwed up for me. So there's a couple of things. You have to create a session. The Azure OpenAI client that I showed you here in main kind of set that up for me. This is like the we're connecting to you handshake. I don't suggest using keys. There's a way to do this a lot smarter. I just did it because it was faster. Shame on me. Shame on me. You can use a service principal or some MSI if you want. And so when it sets this up, this is what does the connecting. And so that's this bit right here. Excuse me. There you go. Notice that when I set up the session, you also saw this thing on the left, this thing, where it set up the session. By the way, it looks like it's actually transcribing what I'm saying, and it's not responding. And so maybe I did something wrong with transcription because the model might have changed. And so we'll figure that out in a second. Because it'd be cool, like if this was like a coming of age story where we figured out how to use the new model that just came out probably today, because this worked yesterday. I had to do a keynote demo with it. Okay, so notice that here it's getting the stuff. This real-time client is a client that I made. And then I send an update to the session so that I can fix some of the properties, and then it's off to the races. So let's look at this real-time client here, because I want to show you how like this very long class that I made to help me actually adheres to this thing. Because as soon as you create a session, real-time.session, modalities, audio, text, like there may be something that I need to fix here, right? For this. As soon as you do that, you basically have, here's the session object, by the way, where you can change like how it works. But then there's a bunch of things that happen from the client that comes into the model, and then from the server that comes out of the model. So in and out. So there's events for this API that come in and out. So for example, if the session is updated, it sends this thing out. So what you're actually seeing here is the session update, or is the session created event. Do you see that? And so I literally just sent that back so you can see it. And then here's my here's the initial system message. But then I update this after it's created, right after it's created. Okay, so that's the first bit. So when I create this thing, I basically initialize this real-time client, and I use the async real-time connection, which is part of, you can see, the real-time API, the beta OpenAI API. So you can see here, Python's nice. You can look at code, right? This is the real-time, the beta async real-time API. So this is their API. And what I'm doing is I'm merging it with the client socket that gives me information. So that this socket right here is effectively the thing that talks to the client, and this is the thing that talks to the server. So for example, I can send it a message, I can send it some audio, I can send some console message. And notice, depending on where we're sending the message, these ones are sending things to the client, which is the website. the client, which is the website. Like if we're sending audio, we're sending audio, or sending things to the console, right? Now for the fun part. This is how we update the actual model. And so maybe I didn't send an update message or something. No, I send the update message. There it is. The update message. Then here is the for loop, the while true loop that does all of this stuff. And while the real time is not none, there are a bunch of events that come out. There's a lot of them. Those many. And each one of those corresponds to one of these. Like, is there a session update? Is there an input audio buffer dot append? Is there an audio buffer commit, clear? And then there's deltas for each one of these. And so, for example, when you saw the model running, and let me start it again, you're going to see some events happening. I'll start this up as we go so you can see. Each of these events actually means something when I get it from the server, and I need to decide, am I going to forward something to the client? Am I going to ignore it, or am I going to do something with that thing? And I want to get through this part because the client side is actually quite interesting too if you're not using WebRTC. So, for example, all of these events like conversation, item created, blah, 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 some of them I don't handle, some of them I do, but I just wanted to have the code here so you could see it. Right. So, for example, when a session was created, notice I sent to the console this message that said, here's the creative. I didn't actually send, maybe that we can debug as we go. Notice I didn't send to the console when the session was updated. So you should be able to see that. So let me restart this thing. And then when I go to this amazing thing, I can connect this. And then when I call, hey, are you there? Yeah, see, it's still not responding, but that's okay. It's transcribing. Notice that we got the initial create event, and now we got the update event, right? So I'm looking at this. Input audio transcription. Maybe this is the thing that's getting me... because I'm not seeing, like, this might be the wrong thing that's going on. Maybe it thinks it's a transcription session, so we'll fix it. Maybe they changed the way the API works for that. So we're kind of having like a good debug moment. But notice that as these events happen, you can see that I'm printing out the event. There's a session created, session updated, a response created, a response done. Let's see. Let's go to the response created because maybe that's where the error is happening. So response. There we go. So let's go to this thing. And looks like I'm not really doing anything with it, but that's really not the thing that I want to do. Notice that when a response is done, it sends these outputs out. So let me show you the events that I do handle because maybe I'm not doing the right events. So there's a response done. This says when something's done. This says when there's a function call to execute it. The thing that's important is the audio deltas. So this is where here we go. So whenever there's an audio delta, that means that there are some bits for me to send. Some audio bits for me to send back to the client. And you can see that. It says, oh yeah, I'm using the, yeah. So Pamela we might debug this together. It'd be great. By the way, this worked yesterday, which was insane. So notice that this is the bit where I actually get the audio stuff to go back to the thing. So let's actually set a breakpoint here. No, I should see response audio done. So response created, response done. Yeah, notice that there's it looks like it's doing transcription instead of like something must have changed, by the way, to make this not work today. So there you go. So every one of these events has something happen. Right? We'll ignore this one for a second. Each one of these functions represents one of these actual API things. And I only handle like a few of them. Otherwise, they're all just passes. Just because I wanted to give you code that was complete so you could see it. So here, if the response is done, I send something to the console. I send a function call or a function call output. You can see, all of that stuff. And then here's another one. If the transcription of the audio is done, I send it back. And then that's it, really. So it's just audio and transcription. But my sense is that I think when I'm updating it, something's wrong here, which I think is what's maybe hosing me. But let's do a little compare here, actually. So when we start the audio real time here, you can see that the audio transcription is null. And here it is not. So let me take it out. Let's take it out. And what harm could it do? It already doesn't work. That was sad but true. Okay, so we'll wait for this thing to refresh. So this is the server end of this stuff, where I literally am mapping every event from the client to the server. Okay, so let's refresh this, and let's see what happens. Maybe this will work. If it works, then we would have collectively fixed all of this stuff, and I will appreciate your help. So let's do this. Let's do this. Let's do this. By the way, this auth.me, when I deploy this to the container, it uses easy auth. And so when it's running locally, it doesn't need it. And so that's why it's getting a 404 there. But when it's running in a container, it uses easy auth to do that. So let's. Hey, can you hear me? Hey, are you there? Why aren't you responding? That's so weird. Because I can see that you're hearing me, but I don't see you responding. Okay. So let's stop that. So that didn't fix it, but okay. But you can see that like the events are going back and forth, which is cool. It's actually much better when it talks back. Like if you're ever like you need someone to like code buddy with, this is a really cool API, although it can get expensive. So that's the server part of this thing. Okay, let me look at some questions here. Can we integrate Azure Custom Neural Voice into the workflow? Yeah, you can do whatever you want. 100%. Yeah, I mean, like I said, this is just like a person in the middle situation where I'm getting stuff from the client, server back and forth. But notice that, like, and I think I want to summarize what I've just done, right? So let me turn this thing back on. I bought a Wacom tablet during the pandemic, so that was my pandemic purchase. So notice that this little bit here that we're looking at is what I would like to determine. You know what? Let me do a. Is there a way to do selection here? So when I grab, let me grab all of this stuff and move it over here. So this is what I would term to be the server side. So server side. Everything that we just talked about, where I establish a socket from the client side, which is, I'm like pointing at stuff, which is over here. And then the server's job is to communicate with Azure OpenAI that has a different socket. So let's so server socket. And what my code does is it effectively allows it. Let me change this so it's like super clear. Soup's clear. Let me thank you. This would be the client side, right? And so there is a client side socket. I'll call it a SOC. And what this does is this effectively manages those two sockets together. That's what this does. And so when you're looking at the code, you're seeing that there's this real-time client. The real-time client's job is to manage the receive from the real-time socket and push to the client socket. And you can see all those events there happening. Push to the client socket. And then this thing also receives from the client socket and pushes to the server socket. And so notice there's like this ping pong thing happening. That's what's actually going on. Why did I do it that way? Well, because the WebRTC client wasn't done when I started this last year-ish. And WebRTC is supposed to make this a lot easier. But if you're building a server-based thing that's supposed to, like, for example, let's just say you have 1 billion audio files that you just want to transcribe, which is effectively what this thing is doing at the moment, which is kind of boring. You could actually do this. Create a socket, get a WAV file, push the bits to the server side. It gives you the text. You write the text, and you could do this over and over and over with all of your stuff, transcription-wise. Okay, so that is the server side. Now it's time to talk about the client side / front end and how we actually make this, how I made this thing work. Yes, thank you. What does this bit look like? Because the problem that we have is like grabbing audio using like a media source and then sending it back and forth is a logistical nightmare if you're doing it in client-side JavaScript, because you could essentially tie up the render thread on the actual browser. So I'm going to start with talking about like something called an audio worklet processor. So now we're pure client side. And notice that on the client side, I have to negotiate things coming out of the server and speaking, and things going into the server so that the middle person can send it to the other and process it, right? So an audio worklet processor is a very interesting a thing that's been out for quite a while. I think 7 years. There was like a revelation that I had, when I started using web workers so I'm going to pretend to be a full stack engineer now. So I'm going to go full JavaScript and React. Okay. So everybody, now we're going to take off our backend Python server hat and OpenAI server hat. And we're going to put on our front end hat. Okay. So an audio worklet processor, the reason why this thing is nice is because it's like a web worker, but it's like it's like a tiny worklet. Exactly. You're like, just use the word, Seth. Instead of a worker, it's a worklet. And what it allows you to do as a front-end dev is it allows you to offload some of any audio kind of processing to the actual audio thread. That's not the UI thread. And so you offload some of this processing to the actual audio engine or whatever pipeline they've set up in the browser. And the reason why this thing is cool is because it effectively allows you to do bidirectional communications without having to encumber your UI. So it's still responsive. It's quite cool. So with us, notice that we need to have both let me move my mouse here because it was confusing. We need to have a way to get audio into our person in the middle code and audio out of our person in the middle code, just like we needed on the other side, right? So notice that this process, it's like, well, Seth, why don't you just call OAI in the back end and be done with it? Well, it's because, like, to be truthful, there were elements of code that needed to be called in here that had secrets that I did not want to expose, or code that was proprietary to how I executed a particular LLM or whatever, right? So it allowed me to segregate things completely while managing the middle. So there's a call from Victor, or a question from Victor. I'm considering combining this real-time with the ability to do phone calls. Yes, we actually did that. If you're using like Twilio, or we have a real-time Azure communication services. All you do is that the middle communication layer, instead of connecting to a socket on the web client side, it connects to a socket on the communication provider's service. So, for example, let me see if we can like quick, because Twilio is pretty popular. Twilio socket. So here we go. So notice that it's talking about how to use a socket with Twilio. You install it. There's an Express app. Notice that there is a call that you're doing, and then there is a socket thing that happens right here. Well, looks like it's doing a voice response, and then it's sending it here instead of like faking things. You get the bits and you send it to your person in the middle thing, and then it sends you stuff back. It's exactly the same. It's just the head of this thing has changed, which is why I also started with sockets, because my demo was actually, it called my phone, and then I talked to it over the phone. And I had to change that because they wanted to show my demo like in New Zealand, and I was like, oh well, I don't want every demoer to be calling my phone. So that's how that works. So the only thing that changes here is what this socket goes to. Okay, so let's talk about this audio worklet stuff and what that actually ends up looking like. There's a little yellow squiggle here. What is this? Not accessed. Okay, well, I'll have to figure this out soon, because I have to show this demo again. So bummer, right? Now I have to fix the thing. So let's talk about the voice client. So this is the actual class in JavaScript that plays it. So if you want to see the actual implementation, this is I made a hook in React that allows me to use the real-time API, and you can pass in like who the user is, what do you do when you get a message, and then what functions should I call whenever this stuff happens. And you can see that there's a call state, and then this is the bit that calls the real-time API. So when I push that, once I push the button to stop ringing, like there's like an idle and a ringing and a call, it creates a brand new voice client. And then it starts the client with the right input device. This is how it like listens to stuff. And then it sends some information to get it started. And then you can see that it does a start and stop real time. Yeah, so the start real time, you can see it starts it. There it is. And then there's a stop real time, and there's a send real time. But effectively, this voice client is the thing that handles the data, the back and forth. So that's what we're going to focus on for this in the limited time that we have. And then maybe we can come back and I can show you how I built the React hook. And then, just to finalize, so you can see the actual voice component in this thing, you can see there is a use. This is the server message that it gets. That's how it pushes stuff out into the terminal. And then you can see that here is the actual usage of the real-time API using a hook. So React hook. All right, so let's look at the voice client, because this is where all the actual work happens. So in the voice client, there is a socket that needs to be created. This socket uses a special way of setting up a WebSocket, because I wanted to be able to like have TypeScript requires you to do certain types. So WebSocket client, this is what it sends, this is what it gets back, right? And you can see in the constructor, you can see how it gets the message. This is how it handles errors, etc. This is the bit that's important. This allows us to do an async await loop on the client side with JavaScript, which is really cool also. and then you can send messages to it. So here is the thing. Notice that when we start, we create a new player, and this player is just a player class that plays any audio and initializes it, and then it has a recorder. And the recorder's job is to hear what I'm saying and convert it and do something with it. Notice that we pass in a function so that it knows how to send stuff, right? And so notice if it's a recorder, this is how it sends audio to the backend. And then if it's a listener, this is the thing that gets stuff and just plays it, right? So let's start with a player, and I'm going to put these side by side so you can see them, because this is where audio worklets really come into vogue. So this is the actual player. Notice that this uses an audio worklet, and it initializes it. And then when it gets data, it plays it. Let's talk about what this audio worklet thing is, because worklets are actually really quite interesting. So let me open this to the right, because this is the side thing. So an audio worklet is actually a separate, completely separate JavaScript class that you load into the audio worklet module so that it can hook into, like, it's like the web worker, right? And notice that what this does is that whenever this worklet gets a message, it pushes audio bits into the buffer, and then it plays them. On a separate thread. So here's the player, right? You can see the player when it's set up. It sets up the audio context. It says this is the worklet node that we're using, which is this one. This is where we're connecting to, which is the destination, which is the output, like where we're hearing it. And then this is what happens when it plays. It sends the buffer that it's gotten from the client and says, audio worklet, play it. And that's what it does. It takes whatever outputs there are and it maps the buffer that's coming in. I know that's tricky, but this works. I'm going to go through, like, I need to simplify this code a lot, but just think of it as here I'll draw. This here code is the thing that receives, bits, buffer bits. That's why it's play. And it's like, you know what? I'm not going to do any work. I'm going to send it to the audio worklet. You do the work and play it. And it does it out of proc. That's why it's powerful. Same thing with the recorder. Let me move this down here. The recorder is a little bit different, though, because we need to tell it what to do a little bit more with the processing to send things back. So this is the audio worklet processor. And because the backend only takes a certain kind of, I don't remember off the top of my head, I haven't looked at it in a while. But notice that we need to convert the audio that's coming from my microphone to int16 that then gets sent back. Notice that this worklet node, whenever it gets a message, it effectively pushes this stuff into the buffer and then says data is available to send. So you can see that anytime anything is processed through the audio worklet, it sends the data back to the UI, to this recorder, so that I can send it to the my man in the middle thing, right? And this is what does the conversion. So for example, it says on data available, and if I go to this thing, you can see there's a function that's on data available. And then when I go to the recorder, not definition, go to implementations, or go to all references. Boom. In the voice client, you can see that when I make a new recorder, this is what I'm doing. I'm getting some data from the buffer because I'm passing in the function. What do I do when there's more bits coming from the worklet? It's saying, hey, do a conversion of this to string and send it to the socket. but we're doing a lot of processing too, right? Like, for example, you can see right here, the thing that's confusing with this thing is you actually have to tell it where is it getting the audio from, and it's getting it from the media stream, right? And you have to tell it how to set it up and how to pass it in. And so let me go to references, you can see that the recorder start.stream. You can see I'm getting the user media, I'm passing in the stream, and then I'm sending the response. So that's what the worklets are doing. There's one worklet for playing audio, and there's another worklet for grabbing audio and sending it to us so that we can send it back. And if this feels like a lot, it's basically exactly the same thing I did on the back end, but now on the front end, because when I start the response listener, you can see that there is an async await. There's a loop for async await loop where it's like, is there audio? Play it. And if there's audio going in, the worklet itself handles notifying the recorder class to send it out. And sometimes there's other events like interrupt. Like if there's an interrupt, like I need to tell the buffer to stop playing. And then this handle server message is what happens with anything that's not audio that we shell out to the user. Okay, so let's do this. Let me draw what we've just summarized here. So to send this thing out, we have our recorder plus our worklet, right? The worklet handles getting the audio and sending it to the recorder, which then sends it via the socket here. Then we have the listener, right? The listener has a worklet, right? So whenever bytes come into here, we process it through the worklet, which then plays it for us so we can hear it. I'm trying to draw the we can hear it kind of thing. There you go. We can hear it. So that's what's happening on the client side. Okay, so the question from Pamela, how frequently does it send your audio? I don't know. I think it buffers it and it chunks it into certain sizes, but I don't know what it is. I bet I could figure it out, but it's been so long that I haven't seen it. This would be on the recorder, the audio worklet processor. It looks like the input length is 0. It puts a int62 buffer. There's the conversion. Yeah, I don't know. But this is hairy code. I think some of the engineering team helped me build this bit because I was like, hey, I need some help. Because it's like converting it to a different format, which is what the audio API expects. Okay. Now, let's see if we can't set a breakpoint and see if we can't figure out what's going on. Why isn't it working? So let me close this here and let me go to the main stuff. And let's make sure that we are actually hitting the right events. And there's a lot of events on the deltas. And so that's why I don't like debugging this thing. But because we're running it here in FastAPI and I'm debugging it, you can actually see all the stuff. So let's go to receive real time. And then let's see if there's delta events. Okay, so let's talk to it. Let's see what happens here. So let's go to this thing. We're still connected. Okay, so notice we have a session created event. We have a session updated event. We have a response created event. Why aren't you responding to me? Let's see here. Why can't you respond to me? Hold on. So maybe is it still? Oh, it stopped somewhere. There we go. And you can see it will continue to just do this as I talk to it, which is unfortunate because it's going to do this forever now. And those are each of the actual events. So let me actually F5 and then take the breakpoint off. Cool. And then we can stop it. and then the socket's closed at that point. Okay, so I only have 5 minutes left, and I'm sorry for some. I don't know why it's not talking back to me. I have to figure out what happened in the change. But yeah, bummer that it didn't do it. Okay, questions. Oh yeah, for pricing, there's some pricing things. I think it's like a certain amount of money for like 20 million for 1 million tokens. I don't know what it is. And one of the events that we will let me just show you how you can calculate things. Go to definition and then let me find not send audio. Yeah, it's just not getting a response.audio delta. Kind of dumb. I don't know why it's not doing that. It literally just did it the other day. Like yesterday. Let me just not say the other day. It was literally yesterday. No. Where? How do I? Because I want to show you the console. Oh, cool. I can do this. And then let me go to the rate limits update. Cool. So now that we've changed this, you'll actually see in the console like actual what tokens count we did. So, but let me just take out the other one because that. Oh nope. Oops. Control F console. Boom. This is too big of a payload. I don't want to send it. Pass. Okay. Oakley dokley. So we'll restart this thing. So stop. Control C. Die. That was dramatic. And keep the questions coming, by the way. Okay, cool. So let me run this again. Would it be possible to keep the transcriptions? Yeah, absolutely. Because like the transcriptions, notice that I'm actually grabbing and sending them. And so that's why I liked having the middle implementation, because I could do whatever I want with the output of the actual thing. So let's go back to this thing and let's start talking to it. And then you can see the rates. Hey, can you hear me? Why can't you hear me? What's going on? Yeah, no, it's not going to do it. I don't know why. It can hear me. It's just not talking back. It's super shy. Kind of a bummer. But okay. All right. Would it be possible? Yes. Once you get the transcription back, you can actually do whatever you want with it. Because like I said, you're just getting the data in your middle tier, and then you can save that, do whatever you want, etc. But I would probably message queue async send stuff so that it doesn't disturb the async await loop from the client to the server, because having those two sockets be copacetic with each other is super important. Any other questions before I hand back? Or maybe we can keep debugging. Yeah, like this literally worked yesterday. I don't know what the heck changed. It's making me grumpy though. Maybe it's this real time. I didn't change this though. Let's take a look at our commit history. No, not that. AI tools. No. Here's our history. Yeah, because I'm on the dev branch. Yeah, no, literally. When did I do this? No, I did this because they updated their API. That was like April 12th. It was like 5 days ago. Yeah, who knows what they changed. Kind of a bummer though. Okay. Oh yeah, finally, where can people grab the code? I literally just released the code this morning. So you can get a look at it. It's github.com, Seth Juarez, Contoso voice agent. I made it public literally the hour before here, so you can go look at it. Forgive my messy code. I wanted to show you like the working version of it. I'm working on a better version of it for other things that'll be released probably at the end of May. So you can take a look at that. But that's where you can actually get the code. So thank you for that. I wanted to make sure that you all knew where to get that. Thank you for your time. That's it for me. Who do I turn it back to?
I'll take it from here. Thank you, Seth.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.